Hi, in this video we are going to solve question number 37 which appeared in GATE 2014 from mathematical physics. The question is the solution of the differential equation d2y by dt square minus y is equal to 0 subject to the boundary condition y at 0 is equal to 1 and y at infinity is equal to 0. So there are four options, so we have to find the solution of the differential equation. So this is basically a second order linear differential equation. Second order linear differential equation. And the dependent variable is y, independent variable is t. So in order to solve this question, let us assume that the solution is y is equal to some exponential rt. Let us assume that this is a solution. Now we'll just put this exponential rt in the equation, original equation, that is equation number 1. We can write this equation 2. So we'll just compute dy by dt is r times e to the power rt. Therefore d2y by dt square will come out to be r square e to the power rt. So this is what, and now what we'll do is that we'll put 3 and 2 back in 1. So that will give us r square exponential rt minus exponential r of t is equal to 0. So this is when you just put 3 into this equation, 3 and 2 back into 1. So we'll get this. Now we can take exponential r to the power t common. We'll be left with r square minus 1. So we take rt common, so we'll be left with r square minus 1 is equal to 0. Now we know by the property that exponential of rt cannot be equal to 0. We know that exponential times is 1 plus x square by 2 factorial plus x cube by 3 factorial, so on. Therefore it's r square minus 1 which is equal to 0, and this is called the auxiliary equation, which will give the solution of this equation will give the roots of the differential equation which we have. So r square is equal to 1, therefore r is plus minus 1. So we've got two distinct and real roots. So the solution is essentially y is equal to c1 exponential r1t plus c2 exponential r2t, where r1 and r2 are the two roots. So we'll just put in the value of roots, so we'll get c1 times exponential of t plus c2 times exponential to the power minus t. So this is the solution which you get. But in the question they have also given some boundary conditions, and the boundary conditions are y of 0 is equal to 1. So boundary conditions. Y of 0 is equal to 1 and y of infinity is equal to 0. So we'll just put the value of t is equal to 0 in the equation, this equation, and get 1 is equal to c1 plus c2. And if you just put infinity, so we'll get y at infinity y is 0, so we'll just get c1 e to the power infinity plus c2 e to the power minus infinity. For the real solutions, we cannot have exponential infinity term because that will not satisfy the equation. So what we'll do is that we'll just this will make c1 is equal to 0, and so from equation this, from equation this, we can say that if c1 is equal to 0, then c2 is equal to 1. Therefore, the solution is y is equal to exponential minus t. Now in the question we cannot see exponential minus t anywhere, so we'll just use another identity. We know that cos hyperbolic t is nothing but e to the power t plus e to the power minus t by 2. Similarly, sine of hyperbolic t is exponential t minus e to the power minus t by 2. Therefore, we just subtract these two, cos hyperbolic minus sine hyperbolic t. What we'll get is essentially this will cancel out, so we'll get exponential minus t, which is our solution. Therefore, y is exponential minus t, or we can also write it as cos hyperbolic t minus sine hyperbolic t. So this is the option D is the correct option, because that is cos hyperbolic t minus sine hyperbolic t. So that is the solution. Thank you for watching this video.